Okay, I'm going to add a couple examples to the videos that have already been posted. I'm just going to work out a couple more of these. Um, this should look familiar, the process of finding the inverse of a function. Basically, the first step is to replace the function notation with y. It's just to make life a little bit easier as we manipulate the equation. Then step two, we interchange any x to a y and y to an x. And then we solve for y, and then we go back to our function notation to show our inverse function. So I'll start with an easy one just to kind of review. So what we're going to do here first, we'll go ahead and replace that with y equals 2x minus 1. And then the inverse function, basically the whole idea of it is that x and y interchange, they switch roles. And so that's what we're going to do. We're going to change this to x equals 2y minus 1. Then we'll go ahead and solve this. We'll add 1 to both sides. So let's see, we end up with x plus 1 equals 2y. Divide by 2, divide by 2. So we end up with y equals x plus 1 over 2. And then go into our function notation. It's going to be x plus 1 over 2 is our inverse function. So that's the inverse function to our original one over here. Okay. So by the way, when you're doing your homework, a lot of the questions, the first question will be, is the graph one-to-one? And I think all of them, the answer is yes, okay? They just want to make sure you can recognize if it's one-to-one, the equation if it's one-to-one. And then the second part will be asking you to find the actual inverse function. So just be aware of that. Okay, here we are on 49. So once again, we'll start by just changing our function notation. All right, so this has a little bit more trickery to it, just the algebra. It's not super challenging. You just kind of have to be a little decent at your algebra skills. So what we're going to do is we'll go ahead and interchange that. So we're going to have x equals 4 over y plus 7. And so what I always like to ask students is, do you like fractions? And 99.9% of the time they say, no, I don't like fractions. So the way we eliminate a fraction is you would multiply both sides by the LCD, which in this case is going to be y plus 7. So I multiply both sides by y plus 7. And what happens here is that will cancel out. Come up here where I have more room. So now I'm left with y plus 7 times x equals, and then on this side all I have left is a 4, right? Okay, so I want to solve for y. You actually have two different ways you can do this. So the first way would be just, divide by x. We'll start by dividing by x, so that will go away. So now we have y plus 7 equals 4 over x. And then we'll go ahead and subtract 7 from both sides. So we get y equals 4 over x minus 7. And that's your inverse function right there. 4 over x minus 7. There actually is a second way you could have done this. And so, hold on one. Okay, I paused and kind of moved stuff around to give myself a little bit more room. So our answer that we got is great. That answer is correct, but I just want to show you another approach to this. The other approach would have been to distribute the x. So you'd have xy plus 7x equals 4. And so we could go ahead and subtract the 7x from both sides. And so we end up with x times y equals 4 minus 7x. And then we'll go ahead and divide by x, divide by x. That cancels out. So we get y equals 4 minus 7x over x. Now, the answer looks different, but actually that answer is the same as the first one I got. If you look at these are actually the same, because if I were to divide each one by x, I'd have 4 divided by x. And then when I divide 7x by x, the x's would cancel out and I just have a minus 7. So if you put either one of these into the computer when you're doing your homework or the exam, they're both correct. They are both correct. Okay, let's try another one. This next one's kind of similar to the one we just did. Okay, so first thing that we'll do is we'll change our function notation to y equals x plus 4 over x minus 3. And then we're going to change the y to an x, and x appears multiple times. Both of those will change to a y. So let's see, x equals y plus 4 over y minus 3. And then we're going to do the same thing we did in the previous question. We're going to go ahead and get rid of that denominator, the y minus 3. So we're going to go ahead and multiply both sides by y minus 3. Okay, so that cancels here and here. And so now we're left with y minus 3 times x equals y plus 4. So the challenge we have here is we need to solve for y, but we have y appearing twice on both sides. And so one of the most common mistakes students will make is they'll subtract 4 from both sides, and they'll say, hey, I solved for y. But the problem is your answer, or the other side, you can't say y equals and then have it y appear on the other side. So what we're going to have to do, we're going to have to do some manipulations here. We're going to basically have to somehow turn where we're seeing two y's into a single y, okay? And so what we'll do here to get started, I'm going to go ahead and distribute this x. That has to take place this time, okay? So I'm going to go ahead and do that. So that's going to leave us with, let's see, x, y minus 3x equals y plus 4. And then what we want to do is we want to solve for y. So whenever you want to solve for a variable, you typically isolate it to one side. So what we'll do here is I'm going to go ahead and subtract y from both sides, okay? And then anything that doesn't have the variable, we'll go ahead and put on the other side. So what I'll do here is I'm going to add 3x to both sides. Okay, so let's see what results here. So on the left side, I still have the xy, and then I'm subtracting a y. Then the minus 3x plus 3x, that cancels out. Then the y, the minus y, that cancels out. And then I'm left with a 4 over here, plus 4, so positive 4, and then plus 3x. Okay, so what I've done so far is I isolated the variable that I'm trying to solve for to one side, and anything that doesn't have the variable is on the other side. So now we're going to do our favorite thing. We're going to factor. What we're going to do is we're going to factor out the y right here. So we factor out that common variable that both terms have here, and that will leave us with x, and be careful, you got to put a minus 1 right there. Okay, so the way you can always check yourself is if you were to distribute it back, you go back to where we were, but we want to go ahead and finish solving. So we actually only have one step left, and that will be to divide by x minus 1. Divide by x minus 1. So that cancels out, so we're left with y equals 4 plus 3x all over x minus 1. Do not start trying to cancel anything out, okay? That's our answer right there. Last thing we'll do is just use our function notation to indicate that that is the inverse function. So let's see, 4 plus 3x over x minus 1. And there we go. Okay, the good news is that's as challenging as we're going to see. Okay, I do have a couple more we'll look at, but this one's the most challenging one. It's not that bad if you look at it. I'm not saying it's easy because it's not, but if you look at each individual step, each step isn't too bad. There's just quite a few of them. All right, so let's see. I had a couple more. Let's see. Sure, we'll go ahead and look at 53. 53 is really not bad. So once again, we'll start out changing it to y equals, let's see, x cubed minus 1. And then we have to change those. Now don't, the exponents stay where they are, okay? So this turns to an x, and then this turns to a y to the third power minus 1. And then now we just have to solve this. So isolate the variables, so add 1 to both sides. So we get x plus 1 equals y to the third power. And then to nullify that power, we are going to cube root this. So we're going to cube root both sides. And so when you cube root the y to the power 3, those nullify each other, so you just get y equals the cube root of x plus 1. And then the last thing we want to do is do our function notation. And there we go. So see, that really wasn't all that bad. Okay. Um, 57 is really not much different from that one, so I'm going to skip that one. And we'll just go to this one last example I have, which is actually going to be the inverse of what we just got done doing, because the operation of cube rooting is the inverse of cubing. And so you'll notice on our next example, we start with the cube root, and so what we're going to end up with is a cube power. Okay, so once again, let's see, we'll change this to y equals the cube root of x minus 8. We'll go ahead and change those out. So we'll have x equals the cube root of y minus 8. And then to nullify the cube root, we're going to cube it. We're going to raise it to the power of 3. And so what happens here is on the right side, it nullifies the cube root. So we end up with y minus 8. And then the last thing we have to do here is add 8 to both sides. So we end up with y equals x to the third power plus 8. And then we just want to indicate that this is our inverse function. So we use our inverse notation. And there we go. So hopefully seeing a couple more examples of how to find an inverse function will help you out, because this is really kind of what you're going to be tested on, is being able to find inverses.